moments of very high concentration for all of the teams that have been working so hard.
À tous de DDO. Attention pour moins une minute. Top. H0, moins une minute.
And we are 1 minute to launch. We are live at the Guyana Space Center, and we're launching Sentinel-1B, built by Thales Alenia Space of Italy for the European Space Agency and the European Commission, part of the Copernicus system. We are launching Microskop, a scientific satellite of the French Space Agency, CNES. And we launched 3 small satellites built by students under the ESA program, Fryer Satellite. Our best wishes to all of the teams.
Attention pour le début de la séquence d'allumage du lanceur. Top, H0-20 secondes. Largage du AVKM. Allumage du triétage. À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Décollage. Lift-off. VS-14.
We are off, hauling ourselves against the gravity of the Earth. 336 tons, the equivalent of 22 buses. And we're heading north, out over the Atlantic, and then over North Canada. So at the moment, Soyuz is burning its 5 engines, 1 on the core stage, 4 on the boosters. The boosters are doing most of the work. Their job is to get us away from Earth and defeat gravity, which makes us stick to our planet. They have a very short-lived job.
Le vol est nominal, les paramètres sont normaux.
All parameters are nominal. They have a short life. They're going to be separated, and you will see them drop on the ground just before 2 minutes in the flight, so very soon. They are powered by liquid oxygen and kerosene. If we get lucky, we should be able to see the separation of the boosters, which is a magnificent sight.
La propulsion du premier et deuxième étage est nominale.
All is nominal on board. Watch for 158. Separation of the boosters. You can't, but I can see the roar of the engine from where I'm staying. So the burn of their propellant, so we don't need them anymore. They fall back to Earth, and we are shedding weight, which is the whole trick of a launch. The lighter we are, the faster we go. So we are start to burn the second stage, or the block A. This will burn for just under 5 minutes. If you look at the trajectory, as we call it, this curve on the right upper corner of your screen, this shows the theoretical path that we are following tonight and the actual path, this white dot. So as you see, everything is nominal. We are coming now to the altitude. Look on the bottom left, where we can get rid of the fairing. The fairing has these 2 shells that protect our precious payload. They protect it from the acoustic vibration at liftoff, the very loud noise, the roar of the engine, and from the friction, the resistance, the pressure, then the air layer are here we go, are exercising on the launcher during the ascent. Here they go, we
Largage
have
de la
jettisoned fairing. We don't need it anymore. We are now outside the atmosphere. And if someone asks you how much time it takes to go to 700 kilometers, answer 23 minutes. This is what it will take us today. So probably less than what it takes every morning to go to work. So we have seen our satellites for the first time, and this is always an emotional moment, even when it is only computer-generated images. Here we see the teams. I'll tell you, they've really worked hard in all these days, and they kept the concentration, and today is the day.
La propulsion du deuxième étage est normale.
So we're coming to the point where the second stage will be shut down, will be falling away, and we will start igniting the third stage. Here we go. We are now burning the third stage. So we launched Sentinel-1A 2 years ago, and we're launching its twin tonight.
Séparation du deuxième étage. Séparation de la vue. Interétage.
On the 14th of April 2014, the European Space Agency launched the first of its new line of Sentinel Earth observation satellites, Sentinel-1A. It was sent into orbit on top of a Soyuz rocket from the European spaceport in Kourou, French Guiana. Now, almost 2 years on, it's time for Sentinel-1B, its identical twin brother.
Sentinel-1B is the first of the second satellites, so to speak. We have already launched the so-called A satellite, and this will help us to have the double amount of data, or only half of the time to wait. In practice, we can get from any place on Earth, we can get within 6 days an image with the A and the B units together.
To achieve this, both satellites will be flying in the same polar orbit, 180 degrees apart, working together as a constellation. They carry a powerful synthetic aperture radar, or SAR instrument. This radar allows the satellite to provide images of the Earth's surface under all weather conditions, day and night. The unprecedented speed and resolution of the Sentinel satellites is providing an unparalleled amount of data, making it a true success for the scientific community worldwide.
It has gone far beyond our expectations. Besides some 80 services which are operational and also supported by the European Commission, there are now national services emerging, and we have 27,000 self-registered users who have downloaded already 500,000 of images, and I tell you, you don't download a radar image if you don't really need it.
The radar images provided by the Sentinel-1 satellites will allow scientists to detect small changes in volcanic activity, routinely map sea ice to help ships navigate through our increasingly crowded polar seas, and allow a better management of shipping routes worldwide. These are but a few examples of the services provided. Sentinel-1A and 1B are not the first satellites monitoring our planet, but they will be the first ones to do this continuously as an operational tool within the Copernicus program.
This is a real game changer, if I can say that. We want to do now, or we do now, what we have done 35 years ago with the meteorological system, operational satellites. That means we will ensure for many, many decades operational services. And this ensures, on the other hand, the users that they invest in new applications, be it governmental or be it private.
The Sentinel-1 satellite mission is an important part of the European Union Copernicus program, for which ESA and the EU are planning to deploy 6 families of Earth observation satellites. Each of these families will address specific needs, and all will provide crucial information to better understand our planet. The information can help mankind to plan a sustainable future for itself and the planet we all share.
And you have heard Professor Liebig, the Director for Earth Observation Program at ESA, explaining which wealth of data Sentinel-1A is already delivering in its 2 years of operation. And with the arrival of its twin that we're launching tonight, and with increased exploitation of Sentinel-1A, by the end of the year, we will deliver to the user 3 times the amount of data we are delivering today. And you've seen, this is the moment of the third stage
Extinction et
engine
séparation du
shut down.
troisième étage.